Welcome to Algebra 1 Honors. This is Lesson 2-1. It's called Basic Assumptions. You're going to learn about some very powerful properties of numbers in this lesson. Okay? Now, on the board we have two challenge problems. If you look at the top problem, right, looks pretty awful, right? Because most people don't like decimals, and most people like fractions even less. Okay? But if we look at this problem and use a couple of properties of numbers instead of just jumping in and starting to calculate, which is a bad habit that very smart people have. They know how to crunch numbers, so they immediately start crunching the numbers. Okay, well, my advice to you is sometimes, just like when you cross the street, it's better to look before you leap. Look at the problem before you start jumping in and crunching the numbers, even if you can crunch the numbers, okay? All right, because if we look at this problem, there's a real simple way to do this problem. If we look at the 9.999, well, if I had 1/10,000th more here, I'd have 10. Well, I look across, and lo and behold, if I added this one and this one together, I'd get 10. So what I really want to be able to do is I want to be able to swap these two numbers there, okay, so that I have this problem. I want to swap this one and this one. Okay, now the property that allows me to do that is called, to swap two numbers, is called the commutative property. Commute, like to commute back and forth to work. Commutative property of addition if we're talking about using it with addition, or of multiplication if we're talking about using it with multiplication. So, swapping and saying that A plus B equals B plus A, which is sort of absurdly obvious to most people, is called the commutative property. But now look what happens when we do that here. This problem now becomes very, very simple. We add these two together and we get 10. And look down here, we even get a double benefit from that. We add these two together, and since they have the same common denominator, I add their numerators, and I get 1,000 over 1,000, and we all know that's 1, so the answer to this problem is 10 plus 1, which is 11. Okay, now, I bet you're smart enough now to see what we're going to do with the second problem. Now, what allows me up here, one more thing, what allows me to add these, to group these two together, and add these two, and then add these two, that's called the associative property of addition or of multiplication. And you can think about that like making associations or neighborhoods. As long as it's addition or multiplication, okay, I can group any number of ones together to add in any order that I want. Swapping the order, the commutative property allows me to do that. Grouping which ones I want to add together is the associative property. So the associative property actually says A plus B plus C is the same thing as if I add B plus C first, and then I add that result to A. Again, sort of blindingly obvious, okay? But it's a very powerful property when you actually use it. Okay? Now, if we look at this one down here, oh, this is another really icky looking problem. It's got a mixed number. It's got this gigantic fraction that will not fit in your calculator. Oh, how awful. Okay? But if we look at it, before we leap into crunching the numbers, we can again use our commutative and our associative properties of multiplication this time to make this a very simple problem. So what we're going to do is we're going to reorder the numbers using our commutative property, and we're going to swap a bunch of things around. So let's see, I'd like to have this fraction right here end up right next to this one because that's its reciprocal. Ooh, so what we really want is this one right next to its reciprocal. So let's do that. Okay, and then, oh, look here, that 33 1/3, if I multiply that by that 3 down there, I get 100. So I want those two next to each other. That little dot is multiply. Remember, it's not a decimal point that ate some helium. It's a dot, meaning to multiply in the middle there. And then we have the 4 and the 25 left. And oh, look, they make a nice group too. All right, now we're going to associate the ones that we want to multiply together. And this becomes a very simple problem. I have 1 here, right, because these are going to cancel. These are going to cancel. I get 1 over 1, which is 1, times 33 1/3 times 3. This will be 99, and 1 more gives me 100. Times 4 times 25, 4 quarters, that's $1. 4 times 25, 100. Okay, and 1 times 100 times 100. Well, 100 times 100 is a 1 with 4 zeros after it, or 10,000. And that's a very simple problem. So again, 2 morals in this lesson. Okay? Look before you leap. Don't start crunching the numbers immediately just because you're a smart kid. Okay? We know you know how to do that. Now you need to learn how to analyze the problem before you jump in and do that. And then second, look and see if the associative or commutative properties will help you to rearrange the numbers to make things a lot simpler. Now, can you do that with subtraction and division? Let's look at that. All right. Let's see if those properties work for subtraction and division. If we have 10 minus 2, well, 10 minus 2 is 8. $10, you take away 2, I got 8 left. Let's commute those two numbers. Let's swap their places and see if we get the same answer. If we take 2 minus 10, that's like having a credit card, right? You have $2 balance, but you spend 10. Well, the card doesn't care. It just puts you $8 in the hole, okay? But positive 8 is not the same thing as negative 8. So it looks like for subtraction, the commutative property does not work. You can't swap the two numbers. Okay? How about for division? Well, if we had 100, we divided it by 5. $100, divided it into 5 piles, 5 people got an equal amount, they'd get $20 each. Okay? If we had $5 and we were trying to divide it among 100 people, though, each person would get 5 over 100, okay, or 1/20th. Okay, of $1. And that's not the same. 20 is not the same as 1 over 20. In fact, they're reciprocals. Okay, so it appears that for division, the commutative property also does not work. 10 divided by 5 is not the same thing as 5 divided by 10. And you can try other numbers to convince yourself too. All right, what about the associative property? That's a little odder one to look at. Associative, remember, means we can group the numbers together however we want. Okay, well, if we have 10 minus 4 minus 3, let's see what that's going to be. 10, we have to do what's in parentheses first. 4 minus 3, that's 1. 10 minus 1, that gives us a 9 over here. And over here, we have to do what's in parentheses. 10 minus 4, well, that's 6. 6 minus 3 gives me a 3. Ooh. So the associative property does not work for subtraction. How about for division? Let's see, we have 100 divided by 10. That gives us 10 here. 10 divided by 2, that's 5. So on this side we get a 5. But when we regroup, when we reassociate over here, and we do the 10 divided by 2 first, we get 5. And then 100 divided by 5 is 20. So the associative property does not work for subtraction or division. Okay, so remember that. File that one in your little toolbox. The only time you can use the associative and commutative properties are when you are adding and multiplying. Okay? And that's what there is to lesson 2-1.